Hello everyone, I am Shruti K. DIXIT, Assistant Professor in Electronics and Communication Department, Sagar Institute of Research and Technology, Bhopal. Today, we are going to discuss about the 8051 Special Function Register. There are two types of registers in 8051 microcontroller, General Purpose Register and Special Function Register. Random access memory, total 256 bytes are there. It is divided into two registers, general purpose register and special function register. General purpose register is 128 byte and special function register is 128 byte. There are there are total 21 registers are there. In case of special function register, the short forms of these different registers are given here. ACC means accumulator. This is the internal RAM address is given, which is in hex form. Accumulator, then B register, addressing external memory, which is the data pointer, higher byte, data pointer, lower byte, interrupt enable, interrupt priority. Then there are 4 ports are there, P0, P1, P2 and P3. Power control, PCON, program status word, PSW, serial port control, SCON, serial port data buffer, SBUF, stack pointer, timer mode control, timer counter control, timer lower byte, timer higher byte, timer higher byte and timer higher byte. This is timer lower byte and this is timer higher byte. So in this lecture we will discuss about the different types of register. This is the general purpose memory having 4 banks are there, B0, B1, B2 and B3. These are the addresses given from 00H to 1FH. This is the bit addressable area and this is the scratch pad area. This each bank consists of 8-bit register. This is the bank 0, address 00H to 07H. 8-bit registers are there, R0 to R7. In the same way, bank 1, the address is 08H to 0FH and registers R0 to R7. Bank 2, 10H to 17H and bank 3, 18H to 1FH. So total 8, this is the 8-bit register. 8 multiplied by 4 means this is the 32 bits are required for these 4 banks. These are the addresses of these different special function registers. This blue background are for input output ports, SFRs P0, P1, P2 and P3. For example, P0 is having 80 address and P1 is having 90 address. We will discuss in detail in the next slides. P2 and P3. This yellow background shows control special function registers, TCON, then T mode, timer mode, then SCON, serial control, I interrupt enable, IP, interrupt priority, program status word. So these are the different yellow color background are for control SFRs and green backgrounds are for other SFRs, stack pointer, data pointer, lower, data pointer, higher byte. So these are the ACC accumulator, B register and these are the addresses given for example this accumulator this address is from E0 to 8-bit register and from E0 to E7. Now the first is accumulator ACC register. It is an, as I have told you, this accumulator is an 8-bit register. It holds a data and receives the result of the arithmetic instructions. It is usually accessed by direct addressing, and its physical address is EOH, E0H, as we have seen in the previous slide. It is both bit addressable and byte addressable. This is the direct address. E0H is given lower, least significant byte and most significant byte. The least significant byte, the E0, and most significant E7, ACC0, ACC1, ACC2, ACC3, ACC4, ACC5, ACC6, and ACC7. If we want to access the bit 1, for example, so E1H, and for the third bit it is E2H, and so on. B register, again it is 8-bit register. It is like accumulator register, bit and byte addressable. It is only used for multiplication and division arithmetic operations. So this is the basic difference between accumulator register and B register. Here the least significant byte F0 and most significant byte is F7. Program status word register, it is again 8-bit register, PSW0 to PS7. This CY, this is the for carry flag. If carry is generated, then it is set. Then this RS1 and RS0 are register bank select 0-bit and register bank select bit 1. For example, if RS1 and RS0 are 00, then register bank 0 will be selected. And if it is 10, then bank 2 will be selected. Data pointer and register. Data pointer register is 16-bit register, and it can be used as two numbers, 8-bit data pointer, DPH and DPL. For it is this 8-bit, this 16-bit register is used for accessing internal RAM and SFRs, and 8-bit pointer and 16-bit data 16-bit data pointer is used for accessing external memory. In this way, this is DPH and DPL, 16-bit register. 8-bit, it is divided into 8-bit registers. DPL, LSB to MSB, and address is 82H for DPL. For DPH, the address is 83H. Stack pointer. Stack pointer is basically for can be accessed using push, pop, call, and return instruction. It is again 8-bit register, and this stack pointer is initialized with 07H. This is the address of stack pointer, 81H, and it is as I have told you, it is 8-bit register, LSB and MSB. For reading the data from stack, means the data is retrieved from the address in stack pointer, and the stack pointer will be incremented by 1. If for writing of data from stack, then the stack pointer will be decremented by 1. Input output register, 4 input output registers are there, having addresses P0 to P3, 80H, 90H, A0H. These are the P00, means this is the least significant bit, and P07 is the most significant bit. Timers and counters. Timers 8051 has two 16-bit programmable timers and counter, which can be used either as timer to generate a time delay, or counter to count events happening outside the microcontroller. The counters and timers in 8051 microcontroller contain two special function registers, T-mode, a timer mode register, and T-con, timer control register, which are used for activating and configuring timers and counters in 8051 microcontroller. This is 16-bit register is divided into two 8-bit register, TL0, timer lower byte 0, timer higher byte 0. Lower byte address is 8AH and higher bit address is 8CH. Again, timer 1 is divided into two types, TL1, timer lower byte 1 and timer higher byte 1. Lower byte address is 8BH and higher byte address is 8DH. Timer mode register, 8-bit register. It is having D0 to D7. This T-con register, timer control register, again this is the 8-bit register, and this timer control register is basically for lower nibble used for interrupt and upper nibble used for T0 and T1. This is the lower nibble is T-con 0, for example, IT0 to IE1, IT0, IE0, IT1, IE1, and TR0, TF0, TR1, and TF1. Peripheral control register, this is used to control the power modes in 8051 microcontroller. The address is 87H and it is both in ideal mode and power down mode. Serial control register is used for microcontroller serial ports, and its address is 98H. It is used for controlling the operation modes of the serial port, baud rate of serial port, and send or receive data using serial port. Interrupt enable or IE register is used to enable or disable individual interrupts. If bit is set, then interrupt is enabled, and if the bit is cleared, the interrupt is disabled. And bit 7 is EAE bit is used to enable or disable all the interrupts, and address is A at H. Interrupt priority is used to set the priority of the interrupt as high or low. If the bit is cleared, the corresponding interrupt is assigned low priority, and if the bit is set, then the interrupt is assigned with high priority, and the address of interrupt priority is B8H. Peripheral data register. Peripheral data register is denoted by SBUF, serial data buffer. It is basically used to hold the serial data while transmission or reception of data in 8051 microcontroller. This is all about the different types of registers, serial special function registers in RAM. Total 21 special function registers we have discussed in this lecture. Thank you so much.